Community, welcome back to the PX4 Developer Summit. I'm really excited to introduce our next speakers. We got Wada Casuso, Principal Product Manager from Microsoft, and Paul Stubbs, Director of Product Marketing for Microsoft AI. They're going to be talking about autonomous drone inspections using AirSim and PX4. Really excited to see what Microsoft team has today for us. So, guys, take it away. Mike's all yours.
Awesome. Thank you, Ramon, and hello, everyone. My name is Wada Casuso. As Ramon mentioned, I work in Microsoft Autonomous Systems. I'm the PM lead for AirSim, our simulation. And here with me, I have Paul Stubbs, too. He is the marketing director for AI and is supporting our organization. Paul and I, we are super happy of being here with you guys today. And hopefully, we will be sharing things that are going to be useful for the community and trying to walk you through the progress that we have been made on the integration between PX4, AirSim, and also including some other Microsoft technologies as well. So that's us. And I think that before we jump to the key pieces of our presentation, I really want to mention this. For me, it's a milestone. It has been a year that, in fact, we decided to become partners and with Drone Code and to be around this amazing ecosystem. So I want to take a time to say thanks for this opportunity. For us, it's super important, and we see an incredible potential on the partnership itself. And I also brought two things here. One is big kudos to Chris Lovett. In fact, he has been a big contributor from Microsoft Research to all the efforts around the integration, as well as Radnesh Madam. If you have a chance to go through Radnesh's presentation, but he presented yesterday, and I think that the recording is available as well. He is one of our key researchers and leading the efforts around the B1 community. So with that, just before we jump to the core content, I would love to very quickly say what is Autonomous Systems. That is our organization, or the organization that hosts AirSim. So our main mission in the Autonomous Systems within Microsoft is to bring intelligence to machines. We believe that through the capabilities of sensing a dynamic world, we can provide safety and support many scenarios that goes from research to industrial applications. So with that, we will have some links at the end of the presentation in case you want to go and take a look at what the team is doing in addition to simulations. But you can do that probably through the links. Now I'm going to hand off to Paul that he has the cool stuff here.
Thanks, Guada. So I just want to show you a quick demo of an inspection drone scenario. And we're really thinking about two main areas of drones for our autonomous systems and AirSim work that we're doing. The first is really inspections, right? The idea of an inspection scenario is that you're trying to get some sensor, a camera or something over some spot on the earth to gather information and take pictures or detect gas leakage at an oil refinery or something like that, right? And the second scenario is around delivery, where the goal is to take some payload to a certain spot on the earth and drop it off in the case of, package delivery or maybe precision farming, right, with fertilizer or things like that. So in this demo is really inspections, which is how do we move a camera around in space and detect objects. So when you go to think about building a demo for drones, it's not just about how do you fly the drone. That's one part of it, and that's a big part. And that's really the part that we'll talk about today, which is around autonomous flight. And then also vision and object detection. So in case we're doing inspections, how do we detect objects that we want to inspect, and how do we detect objects we want to avoid for autonomous flight? But through all of these missions, there'll be other elements, such as a mission builder. How do we know what waypoints to fly? How do we know the weather? How do we know, can we fly? Like all of that is in mission builder. And then we have the other aspects of any solution, which is managing and monitoring, reporting and telemetry and alerts, right? And that's another big aspect of building a drone solution. And then finally, mobile monitoring for keeping up to what's going on with the mission from a mobile device, or other stakeholders can monitor the missions or understand or view the telemetry or manage multiple drones or redirect them or retask them. And so mobile is a big part of that. So for this demo, we really want to talk about kind of the autonomous flight and the object detection sensor part of this. But with any drone demo and drones built with drone code in PX4, we have this sort of generalized architecture here, which is in the top left, we have our flight controller that's running on PX4 or something like a Pixhawk. And then we have a companion computer running, for example, here, an NVIDIA TX2 or an NVIDIA Xavier board. And we run ROS2 on top of that. And we also can run our inferencing and reinforcement learning models on that. And those computers talk to each other through DDS, because ROS2 is DDS compliant. So they talk, the flight controller and the companion computer talk on the drone through DDS. And then we have at the bottom left, ground controller. In this case, it's our Q ground control, and that's talking to the flight controller using Mavlink. And then both of those systems, but more so the ground controller, can communicate with other edge services in the cloud, in the Azure cloud, things like the simulation and sensor information and storing of telemetry and alerting and security for deploying and the other existing machine learning APIs that we have in cognitive services. So all of these elements come together to build an inspection drone scenario. And so for this demo, I put together some hardware and sort of what the canonical example would look like. Starting on the right, I built a mini ATX computer that has, it's an Intel chip in there. It's running 32 gigs of RAM. It's running an M2 SSD, and I have a NVIDIA RTX 2080 as the main processor. And then I have a monitor that I can display, and you can see we're running AirSim, and this is the demo I'm going to show you in a minute. And if my hardware, I'm running a UVified Draco research drone, a Draco R. And so on this research drone, it has a Pixhawk built in, and it has a TX2 board built in as well. And so the demo scenario is that I start with software in the loop, right? I want to do software in the loop to do everything I can in a Docker container on the machine, test all the components. And then at some point, what I want to do is switch over to hardware in the loop. And in this case, I have the drone plugged into the computer. I can deploy the flight controller, the PX4, directly to the Pixhawk hardware, where in the software in the loop, it runs in a Docker container. And then I can deploy the companion computer code, the ROS2 code, directly to the TX2. And that gives me a much greater surface area of testing my solution before I actually spin any propellers or fly anywhere. And so this is a really great kind of dev flow to get back and forth between the demos. And so let's go ahead and take a look at what this looks like. First thing, I start everything up with a simple PowerShell command. So we can go to my source folder and then launch this PowerShell command that will kind of kick off all the elements. And in this demo, you'll see all the elements in that architecture slide kind of come together on one box that makes it super easy for a developer to kind of iterate quickly on what's happening. So the first thing we're going to launch is the PX4 running in a Docker container. So this is a PX4 running in a Docker container that's going to be my flight controller. So once I have my flight controller set up, I'm able to start up Q ground control. Q ground control will then connect to that UDP port to communicate with the flight controller here. And then AirSim spins up as my vehicle simulation. And that connects also to Q ground control and then to the PX4 as well in the Docker container. So also what I have on my companion computer here, once I fire this up, it's actually reading the image messages coming out of PX4, which those images are generated using the sensors in AirSim. So we're getting synthetic image data from AirSim through PX4 that I'm reading in my ROS nodes. And then once I have those nodes coming, what we've also done is I've created a web page for us to have a 2D projection of the world that we're going to see. Let's just rearrange the windows a little bit to give us some space. So this 2D projection comes from the neighborhood scenario that's built into AirSim, and then we can read the messages coming out of ROS and visualize them on this simple web application. So next thing, all we need to do is load our mission so that we can fly around the neighborhood. Now the mission is a simple square that we're going to fly down the streets, and we're going to look for cars parked in the street. So we've uploaded the mission through PX4. Now we're able to start the mission, which then you'll see as we start in Q ground control. AirSim on the left takes off because we're controlling AirSim as our vehicle through PX4. And we start to see the visualization of that telemetry data on our 2D projection in the middle. And then we can start detecting cars. And you can see the sensors that AirSim has out of the box that we can see visualized at the bottom, the different types of sensors that we're looking at. And we can read and infer those sensors. In this case, we're using just a simple YOLO algorithm to look for cars that are parked. So we come up with some cars here, but they're in shadows, so we don't really see them. So this would be an area that we'd go back and test and try to find an algorithm that can detect those cars even in different lighting conditions. So here we see a car that's in pretty good lighting conditions, and we should be able to detect this one easily. And in fact, once we detect it, we just simply put a pin on the map, and we can actually see those cars and log those and save that for later analysis by somebody or another system. So from here, the mission continues. We continue looking for cars, and we continue to fly back towards our waypoints in the center. So I just want to dive in a little bit about the simulation used in here in AirSim and how that really enabled this scenario to really come alive. Now, as I said before, there's lots of lighting conditions that are difficult for computer vision to detect today. And it's not reasonable to ask somebody to fly in these conditions without having a good model yet to train. And so we do that training and simulation. Here we sponsored a team from Carnegie Mellon for the DARPA Subterranean Challenge. And we were able to produce a number of environmental conditions such as fog or smoke in the tunnel that they could train on before they actually even entered the tunnel. And in fact, we created a 3D representation of the entire tunnel system for the challenge. And they were able to fly this mission thousands of times before they even got on site for the actual contest. And so once they're in the tunnel, they can now train it to detect things that were part of the challenge, which are things like backpacks or toolboxes or fire extinguishers or things like that. And so this really becomes a very rich visual environment that you can train your vehicle in either both cases, either ground vehicles or air vehicles inside of AirSim. And in fact, the vehicle that they used for the challenge was actually very innovative. So the challenge required them to fly underground for 90 minutes. But most drones don't have that battery life. And so what they did was they have an AGV that they created, a ground vehicle, and the drone rides on top of the ground vehicle sort of as a mobile battery charger. And so the two work together. So we have a good solution for robot-to-robot communications and swarming, right, and squad type of environments and coordination where they can go together. And when they get to a point where they need to inspect a tunnel, the drone can take off and go inspect that area of the tunnel, come back and charge, and they can continue their mission. So it's a really good leveraging the capabilities for each platform the best, right? And it was very useful to have AirSim to be able to handle both ground vehicles and air vehicles. So with AirSim, you know, it's based on Unreal, and we can then get very rich visual environments. And the environments can be as rich as you want to or need them to be at any point in time. We can simulate city environments or urban environments. We can simulate warehousing and how do we do logistics. We can simulate rich vegetation, and we can do lighting conditions and weather. And in fact, this is the way that many of our customers start, because you want to test all of these scenarios before you take your multi-$1,000 drone out into the field. And in fact, we have a number of enterprise customers doing this today.
Yeah, and let me talk about that. In fact, Paul, I think this is great. I really like that inspection demo because it really shows how an industrial scenario or can leverage the integration of both PX4 and AirSim, and also the cloud, right? That we will talk later about that. But I think that going to the industrial applications, something that I would like to share with the community is two cases mainly that we just delivered last year. One is the CES 2020 demo where we, in partnership with Bell Flight, we in fact implemented a scenario where we provided simulations for training UAVs and being able to operate in a GPS denied environment. So basically, we train swarms of drones to go from one location to that. It can be or can be delivery itself, where you have to go from one location and land and use visual objects identifications for that. And AirSim was a key piece because mainly what we did is train the AI models that were running on the drones to be able to perform the task, as well as we also use AirSim for runtime and visualization. That is something that we are seeing as a big use case now for a lot of customers when they want to ingest real data, telemetry, and use AirSim and simulations in general itself to visualize the current operation and make decisions as they run. And then the other case that I think is it really touches me, this one, because it has to be with wildlife preservation as well as clean energy, is what Air Autonomy is doing now. That is working on turbines inspection. In fact, one of their main customers is Excel Energy, and they are using AirSim for training the drones to perform the missions, be able to monitor and supervise the different turbines, help with any defects that you can have in the operation, as well as also the identification of hazards and the recognition of wildlife around the turbines in order to avoid any accidents. So I think as we move forward, we have many conversations with customers today that are willing to bring their own environments and make sure that they can run simulations to, I think, three different use cases. One is the development, the design of scenarios where they want to try and they want to make sure that everything is safe. And we see individual agents, UAVs or ground robots or the mix of them or swarms. Then we see testing and validation, where in fact regulations are part of that as well. And then the last one is, how do we use AirSim today for the visualization of the operations? So really a lot of potential on this area. And I think that we are all learning too on what are the main uses of this technology. So with this, Paul, I think, yeah, let's talk about deployment. And in fact, we included this last minute in the presentation because this is a new feature that we just added to AirSim open source, and is how to deploy AirSim in the cloud, mainly Azure, that is Microsoft Cloud itself. And based on the use cases, we identified two main needs. One is to use the cloud for development. You can think of this as I really need to have an environment. Today for AirSim is Unreal plus the binaries and other dependencies running in a machine where I need GPU and I need another requirements, and I don't have it in my own capacity now. So I scale that through the cloud. So basically I can deploy a VM, and through different command lines and scripts that we provided as part of this deployment package, you can have the development machine. We are also seeing uses of this as I want to share a demo, and I would love to have multiple developers or sometimes teams around the same simulation environment, so I can share this without the need of really making any infrastructure investment. And the second piece is, how can I test this at the scale, right? And I think that as we move forward with simulations, you really have the need of start testing different configurations, different variables. If you think about the environments, how do I test different weather conditions considering the same scenario itself? So I make sure that the data that I generate to train my autonomous agents is really substantial to get a level of accuracy where I can gain a right fidelity for that. So we made the efforts around this, and we can go to the next part here, Paul. So this is a recording of how the flow works today. If you go to the documentation of AirSim, we added a new section that is AirSim running on Azure. You can go there, you can have the different options, as I mentioned before, where you can deploy your own VM for development purposes, or you can also deploy a container. And I think the documentation is enough to really help you with the testing of this. So I encourage to go through that, but mainly is having the knowledge on how to package binaries and use what we provide currently on AirSim, as well as probably experience with Docker will be super helpful if you want to go this way. And again, I think there are two main scenarios. We differentiated that way based on what we are learning that are the requirements. But as you start using it, we would like to hear more about what is useful for the community. And we included in the site, in fact, a button that says deploy to Azure. In order to simplify the experience, if you just go there and click, you will be taken to the Azure Portal itself. For this, you will need an account. The requirements for VMs are GPU, so you will have to probably scale a little bit on what it is a test account, but you can definitely provision a subscription. You see all the experience as we walk through this. You just create a resource group that mainly is a group of resources, that's to say relevant there, that goes from the VM and all the networking that is needed. You have to give it a name, give it a password to your VM. You can configure the size of your VM. In this case, we provide the baseline is the NV6, and you can check more around VM capacities on the Azure documentation. And then we provide finally scripting to simplify all the experience. And after that, you can review that everything is fine, and then just start the provisioning on Azure. That should be super simple. And as I said, we prepare everything in this template and experience to really facilitate the things for you and make sure that you have all dependencies and everything is ready to go once you continue the path. And we also added support for Visual Studio Code. In fact, we find a way in which you could connect through SSH to the VM that you just spin up and just establish the connection. And once you are there, you are able to clone the repository and just start using and running your simulations. Of course, as this is the case of the development sandbox, you can modify the code and rebuild the binaries and have it that running. And the experience, I think in general, or our goal with all these efforts is to provide you with starting points where, again, you can use the binaries that we have today, or you can create your own binaries. And in fact, the customers that we have, they brought their own environments, and you have to rebuild the binaries as well as probably add some code configuration. But I think that that's the first step that we want to provide to facilitate the adoption of AirSim. And well, as Paul mentioned, I think it's also worth to talk about other components in addition to simulation as well. When he presented the demo of inspection, and when we designed that flow itself, we talk about many potentials there. And one is to really leverage another components of Microsoft as part of that as well. One big is Microsoft Cloud, Azure IoT, and everything that has to be with Intelligence Edge. That brings also capabilities for deployments on the edge, in this case, the drones, as well as to really bring another AI services that could help on that. If you go to our autonomous systems organization, you will also find Bonsai, that is the way in which we provide teaching, learning capabilities, and other advanced reinforcement learning that can be transferred and run in the drone itself to be able to perform different autonomous operations. But this is just a glance of what we are doing today. I think that there is a tremendous potential ahead to really continue integrating the different scenarios. There you have all the links from the resources. And of course, you have the GitHub repo of AirSim, as well as communities around that. We will be happy to chat and learn more about how you are using AirSim today. And again, how do we take this integration to the next level?
Great. Thank you, everyone.
Yeah, thank you.
Thank you, Paul. Thank you, Wada. That was awesome. There's a few questions from the community for you. Would it be okay if I share those with you? We still have time for 1 or 2 questions.
I think we're back to Ramon for some Q&A.
Yeah, I think so.
Yep, you're still on stream. Can I ask you 1 or 2 questions? Okay, so let's do this. I'm going to share the questions with you, and you can help me on Slack answering those. Community, hey guys, welcome. So we're going to have Paul and Wada on the PX4 Slack. Feel free to ask questions there. Our amazing community volunteers have collected all your questions, and we'll share them with them. And join us on Slack for them to get your answers to your questions. Wow, I'm running out of energy, surprisingly, but I still have a lot of coffee, so let's run strong. We have 2 more hours to go. Thank you, Wada. Thank you, Paul. Thank you again. Thanks, Microsoft, for your gracious sponsorship of Drone Code and the open source communities through your gold membership.